Good afternoon, everyone, and thank you for joining us today. My name is Ashish Tyagi, and I work at Genesis Global, where we specialize in building financial-grade applications that are secure, scalable, highly efficient, and FDC3 compliant. Today, I'm excited to take you through a hands-on session where I'll be building an FDC3 compliant application. Our session today is titled as Blowing Away the Mystery, Build an FDC3 compliant application in 30 minutes. And the goal is to show you how straightforward it can be to leverage FDC3 standard to create an interoperable financial application that seamlessly communicates with other desktop applications. Our agenda today is we will be briefly talking about the current financial market, and why FDC3 is important and why it is needed for the financial applications. Then we'll take you through a journey to showcase the Genesis approach to FDC3. And finally, we'll walk you through the code and show you the live application. In today's financial market, integration is not just a technical challenge. It is a critical business requirement. Financial application must connect with other systems, ranging from market data source to trading platform to risk management tool, CRM, and third-party services. The number of these integration can range from as few as 5 to over 100, especially in the case of complex applications like high-frequency trading applications. On the left of the slide, you can see the type of systems that needs to work together. However, this challenge escalates as these systems often have different data model, architecture, and the fact that some of those legacy systems were not built with the modern interoperability in mind. There is also lack of common standard that make these integration even harder. On top of that, business must think about data security, privacy, regulation, and high cost of keeping those systems running. Now, to tackle those challenges, company needs a clear strategy, better data quality, partnering with modern technology providers, and adopt the open standard. And that's where FDC3 truly shines. It offers a standardized framework that enables diverse system and application to communicate effortlessly, breaking down the traditional silos that have long hindered those financial institutions. By providing a common language and a set of protocol, FDC simplify the integration effort, reduce the operational cost, accelerate time to market, and all while upholding the strict security and regulatory compliance. For developers, FDC3 offers a versatile toolkit that facilitates seamless application integration, and that means less time spent on the custom code and more time focused on delivering something that matters to your business users. From business perspective, FDC reduces the total cost of ownership by streamlining those integration process across the multiple systems. And adopting open standard like FDC3 is not just a technical solution, but it is a strategic move. It empowers financial firms to remain agile, competitive, and compliant in ever-evolving financial landscape. Now, let's very quickly recap the building block of the FDC3. At the core of FDC3 are intent, that are action and workflow an application can initiate. Then you have context data, that is the structural information that will be shared among those applications. Finally, thirdly, you have channel that facilitate that communication by broadcasting or receiving that information, right? Then, on top of it, FDC provides an application programming interface, primarily written in JavaScript. And then from the desktop agent provider perspective, we have 3 different things: the application metadata to configure an application, app directory to discover those applications, and desktop agent provider that provide a holistic environment to facilitate this and bring those things together and facilitate the FDC3 interactions. Now, while Finos, FDC3, and then those desktop agent provider has done phenomenal job in keeping FDC standards simple and easy to understand, there is still a moderate learning curve. Why? Because most of the FDC API or the API provided are written in JavaScript or TypeScript with a little bit work done on .NET and Java. So it's very easy for a front-end developer to basically come and adopt those standards, navigate the API. But it is a little bit challenging for a people like me, who's a back-end developer, to navigate those JavaScript API. And that's where Genesis Global comes into the picture. As mentioned before, at Genesis, we build the financial application that are secure, scalable, highly efficient, and FDC3 compliant. At Genesis now, we are treating FDC3 as a first-class citizen. It is a part of our core platform now. And we do understand the complexity building FDC3 application, and that's why we provide full support to declarative and imperative programming. Now you may ask, what is a declarative programming or what is imperative programming? So declarative programming is a programming paradigm which focuses on the outcome of a program or a system rather than dealing with the low-level complexity of it. Like, for example, SQL or HTML, right? You can specify the tag and that will give you the result. Or you can write a query and that will give you the result. And you never have to worry about what is happening in the backend. On the other hand, the imperative programming style focus on doing things step by step or dealing with the low-level complexity. For example, JavaScript, TypeScript, Java, or Python, or any other programming language, because you specify everything deeply. Now, declarative programming is very powerful in this context because it allows developer to focus on what you want to do with the system rather than concerned with the low-level detail of how to achieve it. In this fast-paced and highly regulated industry, declarative programming provides significant advantages. It not only reduces the development time, but also minimizes error and promotes consistency across the different interactions. For FDC3, this approach ensures that system can interact smoothly without the overhead of writing extensive custom logic. Now, for a minute, let's go back to the building block of the FDC3 we just discussed. The two important ways, or the two ways to do the FDC communication are FDC3 intent and the channel communication, right? In Genesis, what we have done is we have built the custom HTML element or web component that you can use anywhere in your web page. And you don't have to worry about any of the TypeScript or JavaScript code. And I'm going to show it today. So the intent, and as in any communication, there is a receiver side and there is an initiator side. The same thing we are doing with the FDC building block. So we have built the intent with the channel so that you can initiate the intent message, and you have the intent listener so that you can listen to that message. For the channel communication, we have channel event and system channel listener. And they are all web component, they are portable, they are easy to understand, and they are easy to use as well. All right. Now, let's take these things in a little bit deep down, how we use it, and what are the channel listener, right? In FDC3 context, a channel is a communication protocol. It broadcasts the information, and if your application is configured, it listens to that information, right? We have built the channel and channel listener. These are, again, HTML custom element, and by providing some attribute, you can enable the FDC communication. Now let me walk you through what those attributes are. So on the left, you see the channel event with providing the event name. Event name is actually the event on the parent. So if you are putting this particular component inside a combo box, so the event name would be on selection. Right now in this example, we are using the channel event inside a grid, and that's why event name is row collect. Right? If you put it inside the button, it would be just a click event. The second thing you're providing is the channel type, which is the name of system channel, or we also know them as color channel. In this example, we have the FDC3 instrument color channel. Then finally, the third argument, you're providing the mapping function. What mapping function does it takes the underlying data from the parent and convert it into FDC3 schemas. In this specific case, we are converting it to the FDC instrument, right? On the receiver side, you have the system listener, and you are specifying two properties. The one is channel type, which is the name of the system channel. So as long as the channel type and channel type are same, you can establish the communication. And then you have the callback method, which is a function to take action once you receive that information. And that function could be calling the backend on that specific information, fetching the data, and modifying the application and showing it to the user. Now, if we take a look at the intent and intent listener, which are similar to what channel and channel listener are doing. The only difference is basically specified by the FDC3 itself, is intent are used for the intent are used when you need to perform an action or a workflow, while channel are generally used when you're broadcasting the information and the receiving application are taking action on them, right? The syntax of both intent and intent listener and channel event and channel listener are same. On the initiator side, you can specify the action here, which is FDC3 raise intent. We are doing specifying the name as create trade, and you're doing it the FDC3 instrument context data. On the receiver side, you have an array of configuration. Now, there's a difference between the initiator, because when you are initiating a specific action, while on the receiver side, you can configure the application to listen to more than one intent. And that's why you have the array where you provide the name of intent and you provide the callback method. Cool. So now that we have covered the basic or the concept, and that's all I'm going to talk, let's see how those things in the practice. We'll take a web application, any web application, we are going to modify that web application, and we are going to make it FDC3 compliant. All right? Well, let's imagine you guys are a trader, and you have several tools to manage your day-to-day applications, right? You have access to multiple applications. In front of you, in blue box, you have the blotter application, which is a central hub of your operation. You can create the trade, and you can manage the position through that. On the left side, you have a news application, which is publishing any local news or the research within the application, within the institution. You have charting application that's displaying the pricing history. And finally, you have the price application. Sorry for the name, but that application is providing you with the reference data when you are creating the trade. Moving to the use case number one, which is the channel communication. Let's see how it's going to work. So what I'm going to do in the next few minutes, I will take the blotter application. Again, all of those applications are independent. I will integrate it with the charting application. So I'll take the trade grid and integrate it with the charting application. Then I'm going to repeat the same thing to showcase the portability side of our web component and integrate the position grid with the charting application. And finally, I will integrate that with the news application. All right? Let's move to the actual things in the flow. So right now, I'm running those applications. As mentioned before, these applications are running in the interop.io. All three applications are there. Let them load. You have the charting application that displays the chart. You have the news application. And then we have the main application, which is blotter application. Now, if we walk through this application, you'll see at the top, you have the trading grid. And at the bottom, you have the position grid, right? I can click any of them, and there is no communication between them because we haven't yet established those communication. Now, from the configuration perspective, we are using interop.io right now, and all those applications are configured like as standard, we configured it. The pricing application and the charting application are running remotely, and the blotter application and news application are running locally on my machine. All right? The news application, listening to the view news intent, Plotter application is initiator, so it's not listening to any of those intent. Charting application is listening to the view chart intent. And then the pricing information is listening to the view instrument and the view code intent. So what I'm going to do, I will just take one of those component, and I'm going to enable that communication through the trading grid and the charting grid. I'm going to save it and then refresh the application. So now what you're going to see is that if I am saying everything right, the trading grid and the charting grid should talk to each other. Well, let's see. And the price change. So with this one line of code, I have just taken the web application and make them FDC3 compliant. Now let's see if we can use those web components and just repeat the same thing again, just copy paste. But that's what we developer do, like 80% of the time, right? Copy paste. So we're going to copy paste. Taking the position grid, pasting it here. Again, going to refresh the application. And when the application is going to come back, now I should see this chart reflect to both position grid, which is now, and the trading grid. Now you may ask, can we use more than one of these components inside a parent? And the answer is yes, you can. So I'm going to copy another piece of code. And put it in the position grid. All right? So the difference now, what is happening is on the trading grid, I'm only listening to the FDC3 instrument channel. On the position grid, I have two different system channels I'm listening to, which is FDC3 instrument and the FDC3 position, which is configured, by the way, with the news application. So if I go back and refresh my application, then you should see that when I click on the position, both news and chart should update. While if I click on the trading grid, only the chart will update. So you can see how powerful those things are. You can enable as many communication as you want. You can enable as many interaction as you want with any of the parent element, right? On one click of the button, you can send the message to 5 different channels, while on another button, you can only send the message to one channel. All right. Now, if you want to see the message flow, what is happening behind the scene, so this slide represents the overall channel flow. What we are doing is we are taking the channel event, and that channel event is listening to the row click on the parent, converting the underlying data into FDC3 instrument message, and this one is specifically for the charting. The news is going to follow the same message sequence. So converting it to the instrument message, publishing it on the system channel, because all of those applications are running on the RAD. Then the channel listener will receive that information, create the filter on the ticker value that we are passing. So we are only passing the ID and refreshing that chart, right? Now, let's see the intent communication in action, how we are going to implement that, how we are doing it. For this use case, we are going to be using 2 different intents. One is the view instrument, which is going to be requesting FDC3 instrument list, and then there's going to be a second intent which will be requesting view quote intent, and that's going to stream the price on the private channel. So for that demonstration, we are using imperative programming style, and I'll show you after this session. And why we are doing that, because we also wanted to focus or show you guys that those web components that we have built in Genesis, they will seamlessly work with the legacy application. So if you already have a web application that is integrated with FDC3 using the TypeScript or JavaScript code, you can still mix and match on any of them. You can put those system channel event on the initiator side, or you can use those web component on the listener side, so that the legacy application is also supported. Now, the overall flow is, I'm going to click on Add Trade button, which is going to open another application. Since it's an intent, it can request the application to respond. And after passing the authentication, the control will return on the create trade request form. Now, what have happened so far is our first intent was requesting the list of instrument from the reference application. So this application, the pricing application, contains the reference data. So if you look at this, it contains all the reference data, as well as it is streaming those price or ticking those price in the live time, in the real time. So far, as a result of the first intent, we get the list of ticker here. Now, if you select any of the ticker from here, you will see, let me open the pricing app, which is here. You will see that those prices are ticking or changing in the real time. So what application is doing, and I will explain in detail when the message flow we're going to talk. What pricing application have done, it has created a private channel, and on that private channel, those prices are streaming in the real time. Then you can select a side and provide a quantity. And when you hit the submit, well, you're going to see several things. You're going to see a notification, a trade will be created, and a position will be created, calculated in the real time. And that will complete the whole flow. And we will close that private channel. Why? Because for the next request, we are going to create a new private channel. Now, let's take a look of the message flow. So what is happening on that message flow? Click on the Add button, we raise the intent view instrument that will return FDC3 instrument list. That will ask for the FDC3 instrument list. Pricing application will return the list of instrument. And on the blotter side, we are going to set this property called intent resolution.source to track the application ID. And why we are doing it, because for the subsequent request, if you noticed in demo, the application was created for the first time when you click on the Add Trade button. You don't want to keep creating those instances of the application. So we are going to track that application ID, and the blotter application will check if there is any application that is running already. And if you find the instance of the application, it will bypass that and create another intent for the same application. When pricing application will receive the second intent, which is the view code, it will create a private channel, and that private channel will return to the blotter application that will call add context method. And as a result, on add context listener will be called on the pricing application side, and as a result, it will create a private channel and start streaming the live prices. So as soon as the prices are changing, they are streaming. Now, when you hit the submit button, the blotter application is going to unsubscribe from that particular channel, and the result will be disconnected. On the pricing side, the channel will disconnect also and will control the flow. But you don't have to deal with all those complexity, because you will use the web component and you'll be using just one line of code, and this whole flow will work for you. And there you have it. In just 30 minutes, we have built a fully functional FDC-compliant application using both declarative and imperative programming style. We covered the basis of FDC3, including intent, context data, channel, and we also demonstrated how easy it is to implement those features in a live application. By leveraging FDC3, we can create the application that are not only powerful and feature-rich, but also highly interoperable with other tools in the financial ecosystem. This interoperability is very essential in today's fast-paced financial market. We would like to thank Finos, FDC3, and Interop.io for this demonstration. But don't go yet. We are hosting a web conference or a webinar on November 6th. Please do join it, because we will be, in that webinar, we will be taking the deep dive on the Genesis platform. You will see more wonderful things, like how to create the application. And you'll be creating those applications from the live, including FDC3. You will also be seeing our AI capability and our 6 different offerings. Thank you very much, guys. Any question? On the receivers, on the pricing application side, what we are doing is, on FDC3, when we are handling the FDC3 ready event, we can add those intent listener here, and it will return the first information, and then on the add context, yes, so we will create the private channel here on the view code event using create private channel method provided by the FDC3 itself, and listen to the instrument view from the backend, convert the data like in the FDC3 format, and then return it. So we are using FDC3 API itself to create those private channels. Yes, I think I will try to answer. That's a very good question. And I think the answer is, when you configure the application in desktop agent, so we're talking 2 different things here, right? My application here, let's just take the example of this pricing application, right, which is deployed remotely, right? So in any of the, like not any, like in a cloud environment, the usual architecture is you have a load balancer, and then you have several instances of those applications running. You can have 1 instance, 2 instances, as many instances as you want, as long as you have the load balancer. And I think that's all hidden behind your URL from which you are accessing the application. So it really doesn't, like, it is really transparent for a user who is using those desktop provider, whether you're accessing the application in the browser or you're accessing the application in a desktop agent. It should work the same way, right? So you will be implementing that high availability on the server side where you are deploying your application.
So basically, let's take an example of your trade listener, right?
Mm-hmm.
Which I'm assuming it's remotely located. Is it?
Trade listener?
Or trade, whatever.
Yeah, so the trade one I was running local, yes.
Okay, so I mean, in a normal environment, you would have to have like a highly available
Yes.
trade processing
Yes.
component.
Yes.
Or set of components.
Yes.
When you mentioned that it initiates like a private channel, there might be multiple nodes of those trade listeners running.
Yes, and there will be multiple private channels.
Oh yeah. So
Yes.
when you are initiating a private channel, it will be to one of those nodes. It will be connected, is it?
Yes.
And what if the connection goes away? How does the system recover from that? What if the node goes down?
Ooh.
I have a private channel with one of the nodes.
Yes. I don't know the answer of this question. I can get back on that. But if I just talk to you from my experience, if the node goes down, your private channel will be disconnected and you will not get that information. So the streaming you saw, that will stop, and you will only display or see the last price that have achieved or reach the desktop agent.
So the question is about recoverability. If one node goes down, how does the system recover or reconnects to another node using another private channel? That's
Well, you have to restart the flow, I guess, right? So you have to again click on Add Trade button. You can handle, actually, very good question. Thank you very much. I think I was skipping that, but I would love to do that. We are doing that in Genesis itself. So trade template. All right. I think I can answer that. So when you specify the listener, if the intent failed, and I think that's what your scenario is, if your intent is failing, then you can implement something similar to show a notification, or if you want to retry, you can specify there as an attribute to your web component that, okay, this is what I want my application to do if my communication failed. Does that answer?
yeah.
All right.
There's a catch condition, right?
Yes. Well, it's always, right?
Yeah.
So in our case, we are just showing a notification, your channel is broke down, there's no communication, do again. But here you can, I think, try to raise that intent again if you want to do after timeout period or whatever you want to do. Make sense? Yes, ma'am.
I have a question about, I think it's really cool how like you just add one line and be able to bring in such information.
Mhm.
Do you have to own the front end and back end of these systems, or like if an API endpoint has like FDC3 compliance, can you just bring it over to your front end?
Yes, so in the ideal world scenario, you should use the entire Genesis platform, which is both front end and back end. Enterprise grade. But, let me show you that. However, if it's not an ideal scenario, then we have this library which you can use. It is FDC, if I search it here. So it's foundation-FDC3 library that we are building. So you can add that in your front-end application, and those web components will work.
Okay, so it doesn't have to be in the back end as well, it just could be in the front.
Yes, ma'am.
Okay.
But that scenario would not be ideal. All right. Awesome, guys. Thank you very much. Have a good one.